This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hi, I'm Lee Bortons. It's Wednesday, July 24th, 2024. Welcome to the Math Map Book Club, where Kirsty Gilpen and I discuss lessons each week from our math curriculum for families with students enrolled in classical conversations communities. We are currently in our summer session, which is ending quickly, and we're working through the curriculum by dimension rather than by lesson, so we can discuss resources and strategies in math education. In other words, more of an overview. So, Kirsty, what do we have today?
So I am excited. Babs is going to share her screen for us because my computer is not cooperating today. Okay. But we have backup systems. And so I'm excited that we're going to talk a little bit more. We've talked before, but we're going to talk a little bit more about what it may look like at the table. So when we're sitting at the table and we have students of multiple ages, what does this look like? So if Babs clicks us through to the math map for us, so here, as we're looking at our math map, you're going to notice something a little bit different to what we've had before. We're going to preview a little bit what this might look like next year when we have multiple print resources available. And so this time next year, as you look at that math map, who can tell us, again, this time next year, not now, but this time next year, which print resources are going to be available to our families, which domains?
Adding monomials, and then also the three that are digital this year, the digits, integers, and fractions.
Yes, so we're going to be adding in monomials. So those Challenge A students this year that will be moving into Challenge B are going to have access to the monomials to use in community, and exactly that. Those digital resources are going to be printed. So digits, digits, integers, and fractions, and the bars in between will be filled in with our digital resources. So this time next year, families will have access to every level from digits through monomials, either in printed or digital form. So before we start, and there we go. So thank you. So before we jump into our table discussions using these domains, what questions, are there any questions that are out there and lingering that you guys would like to address before we start our talks today?
Hey, Kirsty, I've had recently someone asked me about printing the files, the digital versions, and they asked me if somehow through Office Depot or Staples, wherever we get it done, if we had a limit per family, and I did not know how to answer her. So if I have 4 kids and I want them all to do naturals, am I able to do that?
You should be able to do that. Yeah, we don't have any limits at this point on how many people can print or send those files. Yeah, there should not be a limit.
Then another question I had related to that maybe one of you could answer is moms have been telling me they are getting it printed for reasonable amounts of money, $5 to $10, but somebody told me that their Office Depot willing to charge them like $100. So is that about the right price range? So since we're going to have so many printed digital versions next year, I figure a lot of people are going to be asking about how to do it and the cost. So maybe if you could just address that for a minute.
Sure. I think one way that families are keeping the costs down is by only printing in black and white. They may not be printing the color. So that's one way that some families are keeping the cost down. Babs may have some other insight into that. And just to address that question that popped up on the screen, yes, the format will always be in booklets. And early on, in one of the early conversations when Lee and I sat down and started talking about the math map and what that looked like, we talked about a lot of different things, but one of the things that Lee really wanted was for the curriculum to feel accessible to the student. And so instead of being a heavy textbook, right, that just by its very nature sort of dragged a student down, she felt that offering it in booklet form would be a lot more hospitable. The other thing that the booklets allow us to do, because they are self-contained, they have your exordium, they have your math map, they have practice for invention and memoria. They've got the charts for that week, which are your reference, your primary reference for that week, your lesson pages, your solutions for those lesson pages, the careful calculations, which can be a review or a quiz. It's got a game. It's got ways to practice math on the go. So everything you need for that week is in one booklet. And we know that our families are families that are on the go. So they may be visiting grandparents. They may be visiting somebody who's sick in the hospital. They may be on vacation. They may be going to soccer practice or a dance competition. And so we wanted the math map to also be portable for those families, which is why it's self-contained, why all of those elements are in one booklet, so that you're dashing out that door and you can say, okay, everybody go grab your week 13 booklet and put it in your bag. And so that was another reason. We decided to go with the idea of a consumable booklet, again, to make it something that was accessible and portable, but also because you as families can choose to use that consumable resource in a non-consumable way. You can use page protectors, or you can put the work on a separate piece of paper. But if we had made a non-consumable resource, right, so here's your big thick book, that's a lot harder to take and use in a consumable manner. So we really, along with all the things we keep talking about how the curriculum is tailorable for the mathematics education, right? Making you really equipped to lead the math education in your home. We wanted to give you a resource that was also tailorable and hospitable for use at home. So yes, it will always be in booklet format. We are eventually planning to release a resource that will have the charts and the glossary in a printed form, but that product is still in development. So that would be a non-consumable resource when that's eventually released. But right now, those booklets are our primary resource. And again, they're self-contained. We really wanted that to be accessible and usable by families throughout CC and around the world. So hopefully that helps.
Good review.
And just a minute, I want to talk about the printing. So one thing that I did, I made a book and I used the printable one for adults and older students that has like 4 to a page. So this book was $35. And so it was the big giant file. It has all the lessons. They're 4 to a page. Now I also did black and white. I also did double-sided, and then I had it spiral bound, and that was $35. So I think it does cost more the more color you use, but if I had a choice, I would not do color, just because I can see I also have a copy of the complex because I'm using it right in seminar, but that does eat up some of the cost is the color. Now I will tell you this too. I just bought a new printer because, and it was at the recommendation of a lot of people. I asked lots of different people because I like to print a lot. And this is a color printer. It is a Eco Tank. It's a ET 4800. And one of my friends bought one last year and she said she has not replaced the ink yet. And she prints all the time. So that's kind of what I'm hoping for. So I feel like that's a better resource than to send it off to Office Depot now. So 2 different options. And Shauna might have some other ideas too. I mean, she gets lots of tickets and Help Scout, that might help.
Thanks. Lee, can I address the ratio question?
Yeah, you can. Of course you can.
Sure. So when we talk about ratios, there's two ways that we can talk about ratios. And we can talk about a part to a part, or we can talk about a part to the whole. And what we've chosen to do in most of the math map is look at the ratios in terms of part to whole instead of necessarily part to part when we're using them in terms of ways of looking at fractions, because fractions generally are part to whole. So we do have that. We discussed that in the companion. And so what you're seeing on those flashcards is, if I was to look at 1 to 3, we're going to strictly take that and rewrite that as a fraction, as a percent, and as a decimal. If you were to be looking at part to part, you would first need to, you could still write that as a fraction, but you just need to know, what am I talking about? Am I talking about a part to a whole, or am I talking about a part to a part, right? And so that's the difference. There are two different ways that you can think about that, but we generally are using part to whole when we're looking at the equivalences, right? So there may be other places where we ask you to solve things that are part to part, but those equivalences are generally looking at part to whole.
Yeah, and with the little children, where they need to see images to know what the numbers mean, it might be like 2 girls to 3 boys. That's a parts to part. But the flashcards are, like you said, part to whole. Good.
Yes, cis is cosine imaginary sign. Yep, she did a good job. All right. So have we addressed your question so far? I just want to make sure I didn't miss anything.
Oops.
Right. Babs, do you want to pull up the next slide for us, please? All right, so we're going to look first at a question from lesson 2, and you see there we've got our naturals, our fractions, and our monomials. And so this is our question. Discuss the 5 common topic questions using the images. These images are excerpts from the Math Map lesson 2 across the naturals, fractions, and monomials domains. And so we've been given some questions. So I'm just going to go ahead and start with comparison. I'm going to read the questions, and then feel free to chime in and discuss. So our comparison question is, how are lessons similar in each domain, and how are they different?
Well, they're all the power of nothing. All the concepts on each of those pages is the power of nothing.
The form is similar.
Yeah, they all have an Euler diagram in the box on the right.
And they're all, it's all vocabulary building. It's no calculations.
And a lot of the, there are similar terms in each of the levels as well.
Yeah, I'll have the title, The Power of Nothing.
Mm-hmm.
And they all practice flashcards that day.
Yes. The most important part of the curriculum. Yourselves. So they're different in what they emphasize in the sentence at the bottom of the Euler diagram, and in what the Euler diagram, how they build through more and more of the domains.
Which domain is on all 3?
Naturals.
Why is that?
Well, that's where you
The 0 is a natural.
Most basic.
The naturals is a subset of all the other ones.
Another thing similar is they're all about 0 dimension. So I'm seeing that on all 3.
Good.
They all have a point. but then they go on to tell more about it. So each one, it's increasing in the knowledge and the information that's given,
Good.
but it's all repeated. So everything in the first one is in the second one with additional, and then the same with the third.
Good.
And the font, as a result, the font is smaller, so it's about the same size, but more information is within that same concept box. So the font gets smaller.
Good.
I think too, like in the directions, although they're not the same, I almost thought they were because I was starting from numbers and starting from monomials and going up. So I was like, oh, the directions are the same. But so they're not exactly the same because in the naturals it's trace versus complete or right, but the directions are short and to the point in all of them.
Good.
This is not really answering your question, but I just wanted to point something out because I love this picture. It made me think of a family that I talked to that had like an older sibling and a younger sibling. And I remember him saying he looked at his sister's work because her page had the answer to his question. And so like this one, if you had a monomial student and they didn't really know, like, okay, there's 3 blanks there and I don't know where to go. They look over at their siblings that maybe have the fractions. Well, it starts out with a link. So that's a clue, right? And so like you can help each other. Even your younger sibling can help you with your math, right?
I like that, Babs. That's great.
And
That's
you
an
repeat,
encouragement for the younger student too.
yes. You repeat the symbols and like the N for natural, Z for integers. So that's the same and constant through the whole program, and the symbol for point. So you're always revisiting that. You don't modify or change your symbols, and that really helps with the layering.
Great. Well, let's look at the definition questions that we've got here. What is an Euler diagram and what other terms might you like to define?
So it's a diagram of sets. So it's showing what sets belong within what sets. I kind of see it, I love Venn diagrams, so it's like Venn diagrams, but instead of circles next to each other overlapping, they're within each other.
So an Euler diagram can actually be the same arrangement as a Venn diagram. But you're right that a Venn diagram would never be within. It would never show that idea of just being a subset or a superset. That's specific to an Euler diagram. And one of the reasons why is that an Euler diagram, I like to think of it as reflecting reality. And so there aren't any empty sets in an Euler diagram. We are showing sets that are not empty. Whereas a Venn diagram is logical and it shows all our possible sets. So we can show those overlaps, and some of them may be empty, but in an Euler diagram, generally speaking, they should never be empty, because we're trying to show how things do intersect. And so we're not showing all the possible intersections. What are some other words that we might like to define?
Curious, the boxes within, do those have a specific name? Or would you just call them boxes or rectangles or?
Like within the Euler diagram?
Yeah.
Yeah, they're just a way we're showing a different set. Yeah, so I would just call each of those boxes, I would just think of it as representing another set. If they're wholly contained, they're going to be subsets. So we know that that box is a subset of whatever else. Or if it's outside of something, it's going to be a superset. So we can start using our set language and our set notations and definitions to help us understand or describe what's happening in that Euler diagram.
So what would you call them? The one that has under monomials, reals, or rationals is next to imaginary. It's not a superset or a subset.
So they're both subsets of complex, but they are not overlapping in any way.
Right.
So there's not a special word.
No.
And I had a question. I think I had an aha moment today. So the monomials, and as we even go further up in the algebraics, the Euler diagram's really not going to change. It's just how we're using those different numbers in our computations and stuff, right?
Yeah.
Correct.
So that's one thing we've done through the math map is by the time you're done with the monomials, you've definitely seen all the notations and numbers, and you've now begun to not only simplify and calculate with them, but you've also begun to solve with some of them. And what will change is as you go into binomials, you'll get a lot more solving of equations that, have variables that are more complex and that kind of thing. But there's no new notations.
We could create an Euler diagram that shows what, all right, a polynomial or an expression. We could create an Euler diagram to show that relationship. We haven't, but that would be a good exercise for a transcendental student to say, okay, we've seen this Euler diagram for numbers. Now create an Euler diagram for our algebraic domains. Right, so we can create an Euler diagram to show those, but we don't here because our emphasis in 0D is on numbers. And so we're coming back every year and reviewing numbers in those number sets. But that's certainly the type of activity I would expect to challenge a transcendental student.
Hey, is 0 always considered a natural number?
No, it is a matter of debate in the mathematics world. And so there are some people who will vociferously argue that 0 is not a natural number. And there are other people who say that 0 is a natural number. And so that is one of those things where just listening to my kids the other day, we were having a discussion and my daughter said, well, that's why we have to define our terms. Right. This is why we need to define our terms. That when we in the math map are talking about the naturals, we include 0.
Right.
And here's the reason why. It is not because we're really coming down on one side of the argument or the other, but because we wanted to be able to start with the digits, and 0 is a digit, and we wanted to be able to say, here is a usable subset of the naturals are the digits 0 through 9. And so it made sense to make 0 be part of our naturals instead of this weird outlier thing.
Right. That would be confusing. Yeah.
But that's why we're very clear that 0 is part of the naturals for the math map. And it doesn't contradict any standing mathematical laws out there because it is a matter of sort of debate in the math world. All those people can be very fiercely committed to 0 not being a natural number.
And Kirsty, am I right that they want to say it's a whole number? That's the word they would use, or something else?
More generally, so there are some places where it'll say the naturals start at 1, and then the integers are the natural, their opposites and 0.
I see.
So they would say it is an integer. Some may include it as a whole and not accounting. So that's where these sets, some of these definitions are a little bit nebulous depending on the book you read. Whole and counting are not necessarily they're more number descriptions than sets that like a number theorist wouldn't necessarily use whole and counting. Those are words that have generally been adapted to our primary education. And sometimes using 0, putting 0 with the wholes instead of with the counting numbers was one way to differentiate between whole and counting. But again, where we just decided that it made sense for it to be a natural number. And so we're trying to be very clear that we define it that way. So that's a good question.
Also, just for reference for everybody, so she just gave a really great explanation. And you don't want to say to your friend 4 years ago, where was that video where Kirsty gave us that explanation? So what she does is she attaches it to the companion both in the glossary and where we first introduce it to you, so that it's where it naturally would get asked.
Yeah.
All right, let's go ahead and look at some relationship questions. Why do you think we should define integers before we define rational numbers?
Well,
These
you have to-
integers is a subset of rationals.
Right, if you
It
don't
is.
understand what an integer is, then you can't really make sense of what a rational number is.
Because what's the definition of a rational number?
The definition I know is it's a number that can be written as a ratio of two integers.
Excellent, right? So if I say it's the ratio of two integers and I don't know what an integer is, then I don't really know what a rational number is. So there's a great thing where we see that order of I need to know one thing before I know something else. And Donna, you're right that the Euler diagram can sometimes help us to see how things are built. So in order to understand what an integer is, what numbers might I want to understand before I define an integer?
Negative.
Maybe negative, right? That might be something I need to know, or I might need to know what the naturals are, right? So that Euler diagram might help me to put order to the how we introduce our number sets, which if you look at our domains, right, we're building our domains that way. We're first defining what the digits are, then we're going to define what the naturals are, and then the integers and so forth from there. How about a circumstance question? Is it possible for a natural number to be a rational number? Or is it possible for a natural number not to be rational?
I'd say all natural numbers are rational numbers, but not all rational numbers are natural numbers.
Good. And so if we wanted to help somebody understand why all natural numbers were rational numbers, what could we do? What testimony or authority could we point to?
I'm looking at the Euler diagrams. The naturals are all within the rationals, but there are rationals, integers, and rationals outside of naturals.
Good.
So it's just the relationships within the diagram show that.
So what would if I said I gave you the number 4, how could I express 4 as a rational number, as a ratio between two integers?
4 over 1.
4 divided by 1.
4 over 1. That's an easy one, right? Are there other ways I could represent 4 as a
8
rational?
over 2.
8 over
444 divided by 1, negative 444 divided by negative 111.
There you go. So there's so many of them, right? There's an infinite number of ways we could represent 4 as a rational number. But the number itself is 4. We're just representing it different ways, which shows that
Would
it's
you
also
consider-
rational.
If I wrote it just 4.0 and I could put as many zeros, would you consider that rational? Or would you still consider it natural, even though I have the decimal? Just adding the decimal and the zeros, does that then change?
That doesn't change it. It really depends on the question. So a lot of the times when we ask about the number set of a particular number, we're interested in its narrowest set. So what is the narrowest set that it belongs to? And so it doesn't matter if I say 4, 8 divided by 2, 4.0, 4 times 10 to the 0. Right, I can express that number in any number of ways, but it's still 4. And so it's always a natural number, but it's also an integer, and it's also a rational number. And so I can show how I can express it as a ratio of two integers. It's also a real number, and it's also a complex number, right? So I could say it's 4 plus 0i to show how it fits into that complex notation. But it's still 4, and at its narrowest domain, it's still going to be a natural number. What's the best way I can show that not all rationals are natural? So Donna pointed out I can help kids look at my Euler diagram, but what's another way that I could show that not all rationals are natural numbers?
The points that they occupy in the number line.
Sure, so pick one.
So like 3.
Okay, so find a rational that's not natural. Pick one that's a rational but not natural.
2.5.
2.5. Perfect, right? So 2.5 could be written as 5 halves. So there's my rational. It's a ratio of 2 integers, but clearly it's not a natural number, right? So I only need one counterexample, and that's something when we get into proof and we talk about proof. In order to prove things are true, we have to find this logical process that says, okay, here's how all of these things tie together to prove something is true. But when we want to disprove something, the easiest way to do that is to find a counterexample. And you just did that, right? 5 halves is a perfect counterexample. It demonstrates that not all rational numbers are naturals. So great.
And all that conversation should lend itself eventually to your students when they're taking our logic seminars throughout Challenge, because contradiction and contrapositive are all part of that vocabulary too.
All right, last question for this set of pages. Is an Euler diagram the authority for identifying numbers, or is it a testimony of God's authority over numbers?
I think anything we create is going to be a testimony of God's authority. It's just showing us the way he's created them and the way they are, but it's our understanding and a way for us to show it.
Mm-hmm.
Yeah, I was going to say it's simply making an observation of what has been created, just like any scientific endeavor.
So Crystal, how would it be a both and?
Well, because if you use it as a source of authority, if you say, what does the Euler's diagram say about this, then you've used it as a testimony. And yeah, I agree with everyone that it is displaying, we're discovering what God created. So yeah.
Right. Yeah, so it can a both and, right? It's a testimony to God's ultimate authority, but yet it's also providing us with a source of truth, right, in one document. So that's so great. Anything anybody would like to add to looking at these pages from lesson 2?
I
can just say
math is like learning music, or it's like drawing a picture, or it's like learning Latin. All of us in this room, this Zoom room, are very smart and our brains race and we can do so many things at once. And I just find it so peaceful to slow down and look at hardly anything. It's not nothing, it's hardly anything, and have a great conversation for half an hour with you. So thank you very much.
All right, Babs, do you want to show us our next discussion? So our next discussion is looking at 3 pages from lesson 5. We're still looking at the naturals, the fractions, and the monomials. And I picked just 2 of our common topics this time. So we're looking at multiplication, lesson 5, and our look at the domains. And I'd like you to compare the example in the black to the rest of the exercise, right? So that may not be as obvious in the naturals because they're tracing, but I want you to look for the example problem and compare it to the rest of the exercises and see what patterns might be revealed.
And notice that for the naturals, it's all 1 times, and it's the number at the top of whatever you want to call that little two-sided 2 parts or hat or whatever you want to call it. It's 1 times that number. And then in the factors, for the middle one, for the fractions, I guess, is they use the 4 and the 6, and there's only 1 time that you actually have to come up with the factors. So they're repeating, so they're giving you that repetition, but then only you have to come up with the answer on your own the second time or the last time for the 10.
Great.
So it's very simple. It's finding the pattern.
That is the heart of mathematics, is finding the pattern, which is so classical, right? Because it involves comparison. It involves defining what we think is happening, right? So not necessarily just finding a term, but when we think of that, saying, this is what I think is happening, I'm going to write a definition for this pattern, and then testing it to see if it's true. And this is really at the heart of how we're using that classical method to help students learn mathematics. And we keep emphasizing how different this is, because it's not a didactic approach that explains to students what they're going to do and then gives them practice, but instead it shows them through example and then asks them to use their skills of comparison to see the pattern and then complete something that follows that example. I don't know about you, but I remember books where there would be an example and then there would be a problem. And so the example might be this simple, and then the problem would be really complex. And you'd be like, how did they go from this tiny little example to this really complex thing? And so I really want to emphasize that the examples that we're using here, right, they're side by side. They're very comparable examples to what we're expecting the students to do. Yes, Crystal, right? That echo of the eternal well done. I like that. That we're looking for that pattern, and that when we see it, right, when we discover a pattern, that's when the learning takes place. So the grammar is important, and I'm not right, but that understanding is when we go, oh, I see what's happening. That's a lot more meaningful understanding than me saying to a student, here, did you do this? Copy this. But that's how we get to noticing that pattern, is we do that copy work and we're faithful to doing the grammar, so that we eventually get students who are able to see that pattern. So compare now across the domains, and what do you see that they have in common, or what might be different? And I love, Lee picked this example out, and I love this example because it's so clear when it's laid next to each other, of how if I had students in these domains sitting next to each other, how one might help the other. So what do you see?
So the simple trees at the top and the naturals are replicated in the fractions, but the division trees are underneath in the fractions, and they're only used in the monomials. So there you can see the progress of how we use prime factor trees. And one thing I'd just like to point out is, if we were in integers, we could have shown this even more exactly about how it steps through. But in naturals, I'm very limited to 1 to 10. And here you can see I went a little bit over because they're just copying the number above it. So I couldn't have used 24 as an example in naturals. But I could use 24 as an example in and like actually I said naturals, I should have said digits, but I can use it in naturals and integers. So I misspoke. It's just we have this one page where they review their primes and naturals.
Well, if a student has gone through this, then the first one, naturals, is showing you something that's familiar to almost everyone. Might not be for a 5-year-old or a 6-year-old, but it's familiar to everyone. And then it shows you different ways to do it. And then by factors, they're going to be used to the factor trees. So they have that, but then there's an additional step there. And then between factors and monomials, they'll get used to the division, that chart. And so it's taking what they know and adding to it. And this is where I had a parent last night, I did experience CC or the math map. And we were talking about that, and they're like, a lot of them had younger kids, and they're like, I'm at a benefit in this, that my kid will get to step through all of this. And I'm like, yes, you are. it doesn't mean it's impossible for somebody, like we say, with any of the challenge levels, you can jump in wherever. It may be a little more difficult because you're relearning a language, but it really, the program just builds on itself, and that's the beauty of it. And it's not that it looks totally different, this same page in all these books, and that also makes it easy for that one room schoolhouse. We can all sit at the kitchen table and do math first thing in the morning when we're all fresh and just had breakfast and happy, and then we can do our math together and then have that checked off for the day.
Great.
I just want to echo something that Donna just said there, right? If you're jumping into this in challenge, or you haven't started from the beginning, the thing that she said is that you first have to learn the language. And so we keep emphasizing, right, that this first year through, perhaps the first 3 years through, if you're starting in challenge this year, take the time and give yourself and your student the space and the grace to emphasize learning the language first. Right? That we have to, that if you're expecting your student to jump in and complete the work when they don't know the language, right, you're setting them up to be frustrated and discouraged. And so the first thing that we need to do, last week I talked about knitting, and so I've been looking at knitting patterns this week. And the first thing that's on a page of a knitting pattern is it says, here's the steps that or here's the stitches, and it defines its terms. And it says you need to know how to do a knit, a purl, a knit two together, a yarn over. And then you realize there's like all these other steps that are all these other stitches that I'm like, oh, I've got some YouTube time in my future. But it very clearly says you have to know this language before you can read the rest of the pattern. And so it's the same here. Your student needs to know the language. And so if this is your first year going through the math map, give yourself and your student the space and the grace to focus on the language of mathematics before you're trying to understand the more unfamiliar and difficult things that we're going to be looking at. Because there's time, you'll see it. So let's look at definition, and here's some questions. And I'm trying to, on this screen, give you some general questions that you could have really done with any pages, right? I could have taken any page out of the curriculum that was the same page in the same booklet in different domains and ask these questions. So when it comes to definition, what are some words that are in each domain or in all of the domains? And then what do they mean?
Just the word composite, meaning that they have more than two factors.
Good.
So all these numbers must be composite to have more than two factors until you get down to your primes.
Good.
And then it does say prime also. Prime numbers have only two factors. And then just the word factors. What is a factor? It's a number that's multiplied to,
another number
to get a composite.
Or a prime.
Yeah. You have the greatest common factor. Just the word multiply.
Good.
Multiplication.
And you always have the word multiply, but you have the symbol that means multiply.
Yeah. And then you don't always have the word factorization, but you're doing that in each one. And it's just that word doesn't come until the later. At least not on this page. And we also have divide in the monomials.
And then the fractions. Yeah, that's one thing you'll recognize going through. It's very hard to be purely multiplying or purely dividing because the two are so attached to each other. And they're required, you need to know how to divide to do some multiplication skills, like when you multiply by a scalar, that's a fraction. And then all through division, you can't divide if you don't know how to multiply because it's the reverse of it. So we do have things attached like that. If you're only looking for a book where it's just pure, we'll multiply for 1 week and divide for the next week, then we would lose the opportunity to show how they work together.
Any last comments on lesson 5? Generally, Christy, 1 is not defined as a prime number. And I'd have to do some research as to why that is the case. But it's one of those things that when mathematicians make these definitions, they start at 2 and not 1, because 1 is unity. It's sort of this, I don't want to say it's an odd number, although it is odd.
It's its own class.
But it has its own
unique
characteristics and properties.
Mm-hmm. Yeah. 2 is an odd prime. Oh, math jokes.
All right. So as we look at this screen here, I want to point out a difference. So usually Lee worked really hard when she created the lesson pages to take the concepts and the ideas that she felt were really the most important to understanding the concept and put them at the top. And that usually is an image or a graph. So it's usually something that we're doing where we're looking at an image, especially graphs, and they're along the top. Well, in 4D, our 4D lessons, which would be 23, 24, 25, and 26, those 4 lessons, they are actually down the side. So it just made sense to make room on the page to do what we needed to do to put those images down the sides of those pages instead of across the top. So one of the reasons why Lee chose this lesson for us today was just to point out that this is the same kind of idea as what was across the top in every other dimension, but is now down the side. It just gave us that arrangement, just gave us some different things that we could do.
So I needed 5 graphs and you couldn't do 5 across the top.
So now I'm not going to give you questions. I'm going to ask you to create questions looking at these. What are some comparison, definition, relationship, circumstance, or testimony questions that we could ask with our students using these pages?
I immediately am comparing the types of numbers in the matrices within the brackets. They're all naturals and integers. We don't have anything beyond that. They all are within those two.
That's more common to do in textbooks through high school where you go back to naturals and integers because you're working on concepts, not number familiarity. So simple numbers so your brain doesn't have to do 2 things.
Well, and it's also very difficult to diagram 3/4 of a square when it doesn't have the smaller tick marks. So I mean it's just one of those things, and it can be a conversation. Why is it that we're in fractions and we're not using fractions? Or, something beyond whole numbers.
Good.
One of the first things I see, I guess this could be comparison also, but I was thinking of it as circumstance, is where on the XY coordinate graph are we working in each of these different domains? And so like in the first one, we're in quadrant 1, and in the second column, we're in quadrant 3. We're dealing with negative numbers. And then in the last column, we're in all 4 quadrants.
Great job.
Do you guys like that? Because that's one of the ways we've graded through is to go from Q1 and then add more as we go through. So term, hopefully in monomials on, you're pretty much seeing as many options, all four. And then when you get in 3 dimensions, they're hard to draw, but we do have some problems that are in all 8 octants.
So, Kirsty, if I was asking questions with that one, so I have one child on the left. If I was just working with the one child, I would say, let's compare what's similar on the top, what's similar from the left to the right. So then hopefully my child would see, oh, the numbers in the matrix are also in the graph. And then I would say, okay, well, now let's compare the next one. Oh yeah, again, the numbers in the matrix are also in the graph. Okay, what about the next one? The numbers in the matrix are also in the graph. So now I've recognized this pattern. But now if I have a second child, we can start comparing across domains. So what's similar about their matrix and yours? Am I reading that correctly?
Absolutely. Yeah. So I mean, the beauty of the common topics is that we're not limited. And so it may be that I have a student who isn't even ready to make that comparison, but they could look just within the matrix and say, well, the 4s are all the same and 2 is different. Right. So even with my youngest student, I could compare that, and that may not be right. That may not be eliciting the mathematical understanding that we want, that you were getting at, but it's still giving us that chance to practice with and that's where we're going to know our students, right? If I have a student and we're still just working through what are numbers, right? How much is this one? What's that one? Then recognizing that 2 is different is okay. But that understanding is going to come right for this particular concept. I think you were doing a great job of connecting the matrix to the graph, right? What's the same between these and what's different? Then certainly looking at the other domains is going to help us to extend that.
It almost reminds me of 2 things. It reminds me of Bab said earlier, how if I look at monomials, I'm like, I don't know. And then I go and look at, hey, let me look at the naturals, or, oh, now I can go back and understand the monomials. So it reminds me of what she said. And then it also reminds me of just how God teaches us, because, the words Father and Son and all those things are actually meant to help us understand who he is, because his ways are so much higher than our ways. So anyway, kudos to you guys, because it's interesting to think about using a younger child's curriculum to teach you an older child's lesson. So
Yeah, I had someone make the comment to me that, well, the older kids, as they got to understand what the map is, they don't have to do the work, that they could go back and look at the book that they used before, because so much of it's similar. And I just thought, well, I would rejoice if my child went and got a reference book of something they'd already worked through and used it to learn the next thing that they were doing, even if they were just copying it at first. That we just don't value how much repetition helps solidify big ideas into manageable chunks. So,
and usually when matrices are produced, it's not often that they use the smaller numbers, right? So in a traditional textbook, we're jumping into the more complicated stuff. So that's really neat that you can just go back.
I think this is maybe a little bit simpler than that. But one thing that I'm like reading and thinking about, like, I have all boys, and so all of my boys were kind of like, what is the minimum I have to do to be able to play soccer or whatever, right? Like, what is the bare minimum? And so even just in the directions themselves, I feel like it has that repetition that you have to start with the basic. You have to start with plotting. You can't just jump to finding the area. Like, we have to start from here and work our way all the way through, which I feel like translates through when we're doing exposition, and we have to start with the invention and not just jumping through to the, to the elocution part of it. And so I like that too, that it just, everything, you start from here and you work your way through. We don't go from A to Z.
I like to, I just noticed that you used different units on each of in the monomial. Like it's a 1 to, the scale is down there in the corner. Well, you have to pay attention to what that scale is because they all look the same to our eyes, but then our area, the answer we're going to give, it matters. And that's good training to attend to that detail.
I was thinking, I like doing it sort of like how you made the shapes, and to kind of figure out, well, what numbers could I use to make the shapes? What's the pattern of making a straight line? And what's the pattern of making a line slanted this way or this way? And then I was thinking, well, if I could figure out all those patterns, I could create, you know, a picture or a shape. I'm just thinking more like one of those geo boards where you had the you know, the rubber bands and you make kitty cats, or I'm thinking more preschool, but I was thinking, oh yeah, you could figure out, well, what's the pattern for making a straight line if you want a straight line, and then working backward to do that. So I think that's nice to have it so simple, so you could figure it out. You could draw another line or figure it out. I think that's nice.
Good. And I love that you just said, hey, I could extend this activity by having my student graph the picture and then write the matrix, right? So that's a next level of learning. So there's a great example of, again, the tailorability of the math map, that instead of saying, oh, my student already gets all of this and I'm going to just go get the next domain, saying, okay, well, what if you started here? Could you go back? Right? That there's so many ways that I can extend this for my students. That was great. We are getting close on time, so I'm going to go ahead and have Babs look at our next slide. Just to remind you of our curriculum rollout, and we've been talking about 2025, what this would look like next year. And so it is exciting that this time next year, families will have access to all of the domains from digits through monomials. And that includes some that will be digital, and then 2 years from now, they'll all be in print. So isn't that exciting? And I can just give you a testimony to how hard Lee and the team are working to get those ready for you. Babs, can you show the next slide? Thanks. And then just to remind you, for you, but also for those around you, especially as we're going back to community and we're starting to get back with other people. Those of you who have been on the book club, we appreciate you so much. And we've heard so many testimonies from people that say that the book club has been so instrumental in helping them. And so we know that not everybody has been here. Not everybody knows what the support is, but you guys do. And so I'm just encouraging you that when you're talking with people and they have questions about the math map, invite them to come to the book club, invite them to jump on CC Connected and get in the forums, invite them to email in if they have questions. Certainly feel free to, invite them and show them how to access the companion if you've been in the companion. And then starting next week, we're really excited that we're going to be able to offer this because it's been so much requested. We are going to use our book club time to work through each of those lessons using the in-community outline. And so Lee put a lot of time into saying, here is the outline that all tutors should use to work through the math map. It is flexible so that each tutor can meet the needs of her community, but we're going to use that outline and we're going to work through each of the lessons. And so whatever domain you are in at home. So if you're working through the naturals, bring your naturals ex nihilo next week. If you're working through the complex, bring your complex booklet. If you're one of our pilot families, bring your monomials, grab your digits, grab your fractions, whichever one. Yes, Donna, I will add that is Eastern time. And I want to encourage you all to bring the domain that you personally are working in to our book club next week. We will be presenting the complex, but this will be a great opportunity for you to see that you can be in any domain and still participate in that conversation next week. So we're really excited. We will be starting with ex nihilo next week and then going through all 30 lessons over the course of the next several months.
Great.
Any last questions before we jump off?
Just wanted to I try to remind people that these are archived as well. So they can go back and look or re-look or that sort of thing, because that's really handy to know that it's not going to be lost forever. So that's good.
Are the most recent ones available? Last time I checked, they weren't there. So are they back?
They should be. I think that it seems like I get a notification around Monday or so for the previous week being uploaded. So they should be available.
Okay, great.
I'll send a text now and double check. So, thank you, guys.
Thank you.
Thank you.
Bye, everyone.